Hi girls. So we are in chapter 8. Just before we start, girls, just to let you know, we're sort of finalising decisions now as second year maths teachers. But you will have an end of year exam. It will be taken at home. You will be given a timeline. You will be asked to do it online as far as I know, but to submit your workings as well, so that, if, for example, when you do an exam online in maths, it's just a disaster to a certain extent because you have to get the right answer. So you have to type a number in and get an answer. But in reality, you don't have to necessarily get the right answer to get some marks. It's just to get the full marks you would have to get the right answer. So we will come up with a system properly where you take pictures of your workings. You will be given a specific time frame, girls, so it'll be like Tuesday 12 till 2 or something like that. And you'll be given a date. It'll be in the final week of term. You submit your work and that will make up a portion of your grade. I don't know if they finally figured out what that portion is yet. I think it's 60-40, so I think 60% of your grade is going to come from the work that you did before you left me in March, and 40% of your grade will come from that final piece of work that you will do and how you've interacted with me through Edmodo. So make sure you're trying to keep up, girls, because the exam is on chapter 1 through 10. So we just have the end of chapter 8 and 9 to do. So we're flying. We should have a couple of days to do a little bit of revision. So it's chapter 1 to 10. And then what else had we done? We have chapter 21 done. Chapter 17. That's it, isn't it? Yeah, so it's 17. Yeah, so we have chapter 17 and chapter 21 done as well. So they will be chapters on the test. So chapter 1 through 10, chapter 17 and chapter 21 is looking like it's going to be on the test. I haven't got the date and I haven't got the final breakdown, so just don't go telling everybody that Miss Masterson said, because Miss Masterson has said that she's not 100% sure yet on the percentage breakdown, but there will be a final exam. And chapter 8 and 9 are on the exam, so you need to make sure that you're sticking with me, girls, for the next little while. So in the last week we took a look at what it meant to be similar. We took a look at similar triangles. That it's triangles that have something in common. So maybe their angles are the same, but their size is different. The next set of triangles that we're going to deal with have the fancy name congruent triangles. But I'd ask you to take your textbook out, and I'll give you a second now to do this, girls, and just take a look for me on page 160. And I want you to take a look at student activity 8B. So just take a look at the pictures. So I just want you to look at the pictures for a second and think about them. Focus particularly in perhaps on the second picture across with the two girls. What do you notice about the two girls? Okay, think about it. What I notice about the two girls is that they are identical, that they are twins and that they are identical, and that I would find that very challenging to tell those two girls apart. I would have to get to know their personalities, maybe their mannerisms or something, to be able to tell those two girls apart. So if they came into me in September, for the first time ever, I would go, okay, I've got identical twins. I've got to figure out which girl is which and try and figure something that is unique about them. So maybe one wears pink watch, one wears green watch, or something similar. But instantly I would look at those pictures and say they are identical. So congruent is not the same, clearly, as similar triangles were, because those girls are more than similar. Okay. Congruent means that they are the same or identical. Okay? Or the same. So I want you to think about a triangle. What would make, if I was to draw that triangle here, and I wanted to draw a congruent triangle, so that is a triangle that is exactly the same. How could I do that across the way? Now, can I just say that exactly the same doesn't mean that they have to be in the same shape, or shape's the wrong word because they're obviously going to be the same shape. That's the wrong word. This is where normally I pull out a couple of triangles and I show you what I mean. But I don't have anything, well, I have straws and stuff downstairs if I had thought about it, but I didn't think about it properly. What I mean is, if I have two triangles, and I'm just having a look here, maybe I can do it with a sheet of paper. Oh, I don't know if that sheet of paper will work. I'm pretty sure you don't want a video, girls. My armpit, but anyway, sure. Eight. I'm trying to get used to it, maybe. It have to be square. Nope. I need two identical triangles, so it needs to be an identical square. No, like that. Fashion one quick enough, girls, for the video. Okay. I could get my scissors. Right. What I mean is, if I want to draw that triangle, it doesn't have to be facing the same way. So what I mean is, if I want to draw an identical triangle, let's number the sides, 1, 2, 3. I could put one, instead of at the bottom left, I could put one at the top, 2 and 3. Okay. So I could rearrange the orientation, that's the word I'm looking for. So how that triangle is organized could change. This could become 1, 2, and 3. But if I do it right, the two triangles should still be identical. So you don't have to be literally in the same place at the same time to be considered identical twins. So for example, if I'm standing here and I have an identical twin, but she's standing with her back to you, she's still identical to me. Okay? If I have an identical calculator and I have this calculator here and the other calculators like that, they're still identical. They're just not facing the exact same way. So sometimes your mind plays tricks on you, and when you look at things, they don't necessarily straight up, you go, oh, is that identical? How do I know? Well, that doesn't work in maths. In maths, I have to know exactly why I think two things are identical. Okay. So what two things could be the same for a triangle? The most obvious one is the one that I just talked about here, is we'd say this is 3 centimeters, 3 centimeters, and 7 centimeters. If I want to draw the identical triangle, I use my ruler and I make sure the distance between 1 and 3, 7 centimeters, 3 centimeters, and 3 centimeters. Then I know what those two triangles are identical, even no matter which way I twist them. Okay, because they have 3 identical sides. What we call that is SSS. It's concerning, isn't it? For those of you who have any interest in history, SSS is not something that you would normally expect me to be saying out loud. So SSS was in Germany during Hitler's time in World War II. But from a triangle point of view, what I'm saying is those two triangles are identical because their 3 sides are identical. So if you have an SSS situation, that is a situation where all 3 sides are given to you with both triangles and they measure exactly the same, then those two triangles are considered congruent, and the word we use is congruent. Identical. So they are congruent triangles because their 3 sides are the same. You turn over now, girls, in your textbook and you take a look. That's case number 1 on page 162, where the 3 sides of the triangle are the same length. They don't always measure it, put numbers to it. So they might, like you see in case 1 there, they'll put 1 tick here between 1 and 2, 1 tick here, then I put a 2 tick between 2 and 3, and a 3 tick. That means that those sides are the same and the same measurement. So like they've done in case 1 in your book. So that's one way in which 2 triangles can be described as identical. So they're identical because their 3 sides are the same. So that's one way. We take a look at another way that 2 triangles could be considered identical. Can we take, and this is one thing I want you to think about now before you go any further, if the 3 angles were the same, identical, so we'd say it's 60 and 60. And I have another triangle with 3 angles that are 60, 60, 60. Are those triangles identical? Just think. And the answer to that question is no. That was what similar triangles were all about. So I could have a triangle over here that was completely different in size, but still had the same angles. 60, 60. It's called an equilateral triangle. You're going to have equal sides, etc. You might have equal angles, but they're not the same triangle. So those two triangles are clearly not identical. Because this one is much, much bigger than this one. These triangles are similar. So there is no situation where just the three angles are enough to give you a situation where you can say that they're identical or congruent. So if we take a look at the second one that they have in your book, again, something we shouldn't really be saying, SAS. So SOS is a normal one, but SAS. So if you have two sides the same in the triangle, so we say this one's 6 and 7, and over here, this is 6 and 7, and the angle between them is the same. Angle between them is the same. We can say that those two triangles are congruent. That is, that their third side must be the same length. Okay, but we would say that these two triangles are congruent because they are SAS. They have two sides the same and one angle the same. Okay, and case number 3. So that's case number 2. Case number 3 is where you have an angle, a side, and an angle. So this is where you have angles and sides. So this one and this one, and this side are the same on this triangle over here. You've got this angle and this angle, and this side are all equal. And those two triangles must be equal, and that is, must be identical. And they're based on an ASA sort of side. So when you see two triangles, you look at the two triangles and you see, well, do they have three of the same sides? Do they have two of the same sides and the same angle? Or do they have two angles the same and one side the same? Then they are considered to be congruent. So anytime you see a triangle, it's the first thing you take a look at. Now, case number 4, girls, is what we've already done in chapter 10, which is trigonometry. Okay, and that's taking a look at where you have a right-angled triangle. So you have one angle is the same in both triangles. The hypotenuse, a right angle, and the hypotenuse and a right angle of the other side, they're always going to be identical. If you take a look at case 4 in your book, girls, this is called a right-angled hypotenuse side. Okay, so if you have two right angles, you know you have two angles the same. If your hypotenuse is the same, and one other side is the same, then you know those two triangles are congruent or identical. Okay. That one we'd already done in chapter 10, where we took a look at right angle triangles. To be the same, you would have to have a same angle and two the same sides. You could argue that's an SAS, and it is an SAS, but it's a special type of SAS, and that's a right angled SAS. Okay, so right angle triangles go on their own. They have their own chapter. They have Pythagoras. They have a whole load of extra, I was going to say extra chemistry, but extra maths involved in them. So that case 4 is the one we'd already take a look at. The rest of the chapter really only focuses in on chapter 1, case 1, case 2, and case 3. And what it does, girls, is it gives you pictures. So if you take a look at page 163, it gives you pictures of triangles, and it asks you under what rule are they the same? So is it an ASAA, is it an SAS, or is it an SSS triangle? And that's all you have to write down beside it. So you have to say, yes, it's congruent, or no, it's congruent, and why it's congruent. So if I take a look, for example, if I just take a look at page number 184 and I look at part D. Okay, so 184 part D. And I'm going to give you a few of these now for your homework. Say, those two triangles are yes congruent, so I would say yes congruent. First part of my answer. And the second reason is it's an SAS. That is under the SAS rule. That is, they have two sides and the angle between them is the same. And that's all I would write down. So my answer is yes, congruent SAS. Okay. So I'm going to ask you to take a look at a couple of those questions for me, girls. So that's page 164. And we'll take a look. I did part D. I'm going to ask you to do E to J. to J, and that's all in question 1. And we'll come back and take a look at the end of this chapter then the next day. Thanks.